Hello everyone, welcome to the video. Today we're going to be looking at section 4.4 where we're going to be factoring polynomials. So our essential question is, how can you factor polynomials? Basically there are different ways that you can go about it depending on how many terms a particular polynomial has. You know, when it's a trinomial, you're trying to get it into, a product of two binomials. If it's a binomial, is it a sum of difference pattern? Is it, if it's four term, we're grouping it, stuff like that. So, we have done some of these things in the past in other classes and other lessons. And like I've said before, and hopefully others have said before, it takes practice to try to formulate how we factor those things completely. So, looking at these examples here, we are going to ask you to factor these polynomials completely. So for part A, we have a trinomial x cubed minus 4x squared minus 5x. Anytime they ask you to factor it out, oops, sorry, if they ask you to factor these things out completely, I always initially say, okay, is there one term that we can take out and put in on one side of the parenthesis and then move forward from there? Well, they all share a common variable x, so I can actually put x to the outside and then fill in what's left over. What's left over is going to be x squared minus 4x minus 5. So now what we have here is a simple trinomial. Let's see if I can factor out that trinomial. So x goes here, this goes parentheses, parentheses, x here and x here. They're going to be different signs because of the minus 5. Larger numbers are going to be attached to the minus because of the minus 4. Two values that give me a product of 5, but their difference is 4, is 5 and 1. And then the final thing is I just see if I need to factor any other of those parentheses even further. X minus 5, no. X plus 1, no. And x, no. So this is my factored out completely polynomial. Looking at B, same thing like A. Let's see if there is a term that I can put to the outside and then see if I can factor any more from there. So I have coefficients of 3 and the negative 48, or just 48. Uh, 48 does in fact go into 3, goes into 3 16 times. So 3 can go to the outside and they both share a common variable y. So, and the smallest degree is y to the third. So what's left over would be y to the second minus 16. Now, what I have here inside the parenthesis, I have a sum and difference pattern, which means that I can write this as 3y to the third, and then this is going to turn into y plus 4 times by the quantity of y minus 4. And again, C is very similar to like A, but again, um, I encourage you to work at it, and if you have any questions, please leave comments down below. Let's look. I'll do number 3 here. Again, these other ones, take a look at them, see if you can work them out. If not, again, please comment. We'll go from there. With this problem, I can factor out, looks like everything's divisible by 8, so I can say 8, and there's an m, the smallest one's to the third, so what's left over is going to be m squared minus 2m plus 1. Yeah. So I go from here. This is going to be 8m to the third. This is a simple trinomial, so parentheses, parentheses. I got m, same sign minus. Two values give me a product of 1, but their sum is 2 is 1 and 1. If you left it like this, that's fine, but you can also write it as 8m cubed times by the quantity of m minus 1 quantity squared. This is acceptable, and so is this. The new concept or new formula that we'd be looking at is the sum of two cubes or the difference of two cubes. Now, how are you going to be able to identify what set of um, set of binomials is going to be a sum of two cubes or a difference of two cubes? We're really familiar with the perfect square numbers because we take square roots all the time, but we're not as familiar with the perfect cube values. Those are things that you can take the cube root and the result is an integer. So like 8 is a perfect cube number because if you took the cube root of 8, it would be 2. So if you were to try to take your calculator and write in 8, and this is, so if you took this little, and then in parentheses to take it to the third, you just go 1/3 power. That means it's the same thing as the cube root would get a value of 2. And then I believe 27 is the next one. If you took the cube root of that, it would be 3, and it keeps going, so on and so forth. So essentially, you'll have to be able to identify those and see if those are, in fact, perfect cube values. So, like they have here, in this example, 64 is a perfect cube because the cube root of 64 is 4, and 1 is a perfect cube because if you took the cube root of 1, it's still 1. 27 we said was 3, and 8 was 9. So like all you gotta really do is figure out what those cube roots are, and then you'll be able to establish what your A and B values and then substitute it into either this formula or this formula depending on if it's a sum or it's a difference. So let's take a look at some examples to see if we can formulate a factored out polynomial. So in the first scenario, they want us to factor x cubed minus 125. So the first thing is you have to ask yourself, especially we just identified with the sum of two cubes or the difference of two cubes, is x cubed perfect cube? Yes, it is, because if you took the cube root of x cubed, it would just be x. So that means in this case, a is going to equal x. Here, we have to say, okay, is 125 a perfect cube value? Well, if you took 125 and you took the cube root of that, yes, it would be 5. So that means b is going to equal 5. So using the formula of, in this case, it's difference, it's going to be x cubed minus 5 cubed, because this means that is there, and that is going to be equal to, in parentheses, a minus b, so it's going to be x minus 5 times it by the quantity of a squared, which is x squared in this particular case, plus a times b, which is going to be 5x, plus b squared, which is 25. Now you're going to try to you may attempt to try to factor out x squared plus 5x plus 25, but you cannot because there's no two values that give you a product of 25, but their sum is 5. So this is your factored out completely polynomial. If you look at B here, I have 16s to the fifth plus 54s squared. So in this particular problem, we can actually factor out a single value. 16 goes, I know they're both divisible by 2, so yeah. So now I can say that 2, and then they share a common variable s, and that will be 2s squared. And what's left over is going to be 8s to the third plus 27. So now what we have inside the parenthesis are two terms that are perfect cubes. 8s cubed, so that means that a in this particular instance is going to be 2s, and b is going to be 3 because the cube root of 27 is 3. So I have this 2s squared on the outside, that doesn't change. And then this can be factored in, so 8s cubed plus 27 is going to turn into a plus b, because it's a sum of two cubes, so it's going to be 2s plus 3 times it by the quantity of a squared, so it's going to be 4s squared because you have to square both of those values, minus the product of a and b, which would be 6s plus 9, because 3 squared is 9. So that's what that one's going to look like. Here we have four-term polynomial. So we have to go by grouping. Again, remember, anytime that you are using a grouping, you have to make sure they're in standard form. So 3, 2, 1 constant, we're good there. I always rewrite it, even though it is in fact in standard form, to help you with the signs. Group it up, these two and these two. Factor between z cubed plus 5z squared is just going to be z squared. What's left over is z plus 5. I got the minus, so I write that in. Between 4z and 20, it's going to be 4, and that's going to be z plus 5. Reason for that, again, these two should be the same. But if you think about it, negative 4 times it by z is negative 4z. That's consistent. Negative 4 times by positive 5 is negative 20. That is also consistent. So I have z plus 5, and then in this set of parentheses, what's left over? Z squared minus 4. To make sure that we factor it out completely, this one right here is a sum and difference pattern, so I can write in z plus 5, and then this turns into z plus 2 times it by the quantity of z minus 2. Again, I would encourage you to look at these problems, but if you have additional questions, please comment down below. I'm more than happy to look at those problems with you. Here we have what is called the factored theorem. It says a polynomial f of x has a factor x minus k if and only if f of k equals 0, which basically means is if you were to put that set of parentheses in a graphing calculator, or that polynomial in the graphing calculator, you should get your graph should cross the x-intercept at that specific point, which means that the equation is going to be a 0. So here it says, using that factored theorem, it says that determine whether x minus 2 is a factor of f of x equals x squared plus 2x minus 4. And they want you to, the next one is x plus 5 is a factor of 3x to the fourth plus 15x to the third minus x to the second plus 25. So what you are going to do is you are going to essentially, just like what you did in the previous section, you are going to take the opposite of how it is written when you're using synthetic division in order to determine if x minus 2 is a factor. So what you're going to do is you're going to plug in 2 right here, and rewrite this as a coefficient. This is going to be what, 1, 2, and negative 4. If x minus 2 is in fact a factor, your remainder, or at the end result, should be a 0. So I drop down the 1. 1 times 2 is 2. 2 plus 2 is 4. Sorry. And then 4 times 2 is 8. Negative 4 plus 8 is what, 4? So I have a remainder of 4. It needs to be 0. Since it's not 0, that means that x minus 2 is not a factor. So x minus 2, not a factor. So let's look at part B. So if I go with x plus 5, it's going to be the opposite. So it's negative 5, 4, 3, 2, 1. So we're good. So it's going to be 3, 15, negative 1, 25. So drop down to 3, negative 15 here. This turns to 0, 0. Oh, I'm missing a 0 here because I don't have an x to the first. So this is negative 1. This is positive 5. Drop down, this is 5. Negative 25, and I get 0. So I have 0 at the very end. Since it needs to be 0, I can say that x plus 5 is a factor. Here it says shows that x plus 3 is a factor of x to the fourth plus 3x cubed minus x minus 3. It says then factor completely. So I'm going to write in the negative 3, put it in here. I get 1, 3, there's no x to the second, so it's 0, negative 1, negative 3. Drop down the 1, I get negative 3, I get 0. Multiply that, gets me 0. This gets me 0. I get 0 here, -1. Multiply it together, I get 3, and I get 0. So show that x plus 3 is a factor. I just proved it by using the synthetic division. But here they want us to now factor it out completely. So this is your remainder. This is your constant value. This is your x to the first, x to the second, and this is x to the third. So since these two have zeros, I don't have to write those in. So my polynomial that came from this is going to be x to the third minus 1. But you also have to take into account that this was a factor, so we place it in, so it's also going to be x plus 3. So because they wanted you to factor it out completely, we have to make sure that we didn't miss anything. All right, the x plus 3, that's shown right from there. But what we have here is we have the difference of two cubes, because the cube root of x cubed is x, cube root of 1 is 1. So this is now going to be x minus 1 times it by x squared plus x plus 1. And then the x plus 3 is there as well. And that would be my factored out completely polynomial for that particular situation. And that is being able to factor polynomials. Hope this helps. Until next time.